Hello Internet and welcome to Sodium Hypobromite. Today we're going to talk about molecular bonds. More specifically, we're going to be talking about ionic and covalent bonds. In the last video, I spoke about why atoms form bonds and I used water as an example there. So now let's continue with that and explore how water is formed. Water is an example of polar covalent bonding. First, let's explore the covalent part. So, covalent bonding is when atoms share their valence electrons, as you can see here. So, what makes water polar? A molecule is polar when there is an unequal distribution of electrons. This occurs in H2O because oxygen is more electronegative than hydrogen. This makes the electrons more likely to be closer to oxygen. This gives oxygen a partial negative charge and hydrogen a partial positive charge. Other polar molecules include things like hydrochloric acid or ammonia. Now, let's see what nonpolar covalent bonds look like. For examples of this are carbon dioxide or oxygen molecules and nitrogen molecules. Now, let's imagine two oxygen atoms forming an oxygen molecule. With the same electronegativity, the electrons are distributed evenly, which makes the molecule nonpolar. This also occurs with molecules having different elements but similar electronegativity. But what about salts, such as sodium chloride? Well, sodium, when alone, has an extra electron, and chlorine, when alone, needs an electron. So sodium gives its extra electron, becoming a cation or a positive ion to chlorine, which becomes an anion or a negative ion. This bonds sodium to chlorine and vice versa because the charges they now have are equal and opposite, and well, opposite charges attract. Ionic compounds have an interesting property. Let's see what it is with sodium chloride. When a sodium atom loses its electron, there is nothing keeping it bonded to the specific chlorine atom except for the charge that they both have now acquired. However, there are a lot of sodium and chlorine um atoms or ions, so sodium ions and chloride ions in a sodium chloride crystal, which are all attracted to the atom or to the ion with the opposite charge. Now this forms a sort of lattice structure, which you can see here. This also gives ionic compounds higher boiling and melting points. Unfortunately, I couldn't talk about sodium hypobromite. I mean, it is an ionic compound, but more details are a topic for another day. Well, guys, thank you so much for watching. I hope you enjoyed this video. You can watch my previous video here, and if you enjoyed this video, then subscribe.